Hello everyone, this is JJ. This video I will introduce definite integrals. So, according to the definition, definite integrals, it means, look at this. There's a curve, represent function fx. So, definite integrals means to calculate the area formed by x equal to a, x equal to b, x-axis, and the curve, the area of the shape here. So we can write it like that. So there's a better explanation about the sign here. Is because the thing we are doing for calculating definite integrals is calculate the sum of function output times with dx, which is infinitesimals, like that. So what does it mean? So basically, we can, in order to, it's hard to directly calculate the area here, but instead we can cut the thing like the area, the shape like that. Cut them with many vertical straight line. And for each two straight line, we can create form a rectangle. Like that. Then obviously, the area of sum of this rectangle is not equal to the area under the curve. However, it's pretty close. So the only thing we have to do is make the width of the rectangle getting smaller. If we say the width of the rectangle is dx, so the thing we are trying to do is making dx getting smaller, approach to 0. Therefore, we are basically calculating the sum of the function output. Why? It's because for each rectangle, basically the length of the rectangle is equals to fx, the width of the rectangle is equals to dx. So we are basically calculating the sum of fx times dx. That's why it's like that. Cool. So, but how can we calculate definite integrals? So we have Newton let's say we have Newton Leibniz formula. So we know that definite integral is equals to fb minus fa. So fx is one of the original function of fx, like that. So it's a relationship between definite integrals and indefinite integrals, because we only can use indefinite integrals to calculate to find the original function, right? But why it's like that? So I will introduce a method. So the thing we are doing here is static is static, yes. So basically we are calculating like if we know A and we know B and we have to calculate for this function, calculate the area like that, right? But actually, similar to plus this operation, we can think it as a function with two variables. Think about it. A plus B actually is just a function, but with two variables. So function plus AB, it means A plus B, such a thing like that. So we can always also deal this thing as a function. So how can we do that? So let's fix A as a constant. And then we let B change. Okay? So we find we find a function. Let's call it as GT, okay? GT is equals to definite integral with A and T fx dx, okay? So what's going on with here? What will happen if we change the t? So let's draw the graph. Okay, there's a perfect. Okay, so A is fixed right now. Oh, Jesus Christ, it's not going to come. Oh no. So A is fixed, and T is variable which will change. So T can be here, T can be here. It's T1, it's T2. So basically, the function describing, for example, when T is equal to T1, GT is equal to area of those parts, 1, 2, 3. And when T is equal to T2, the output, the GT is equal to the area here, 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 like everything, like that. So, if it is a function, then we can try to calculate its the derivative. How can we do that? So according to the definition of derivative, we know that g derivative t is equals to g t plus delta t minus g t divided by delta t. However, here's a limit, so delta t approach to 0. What does it mean? So remember how I explained something here. For example, let's say this here is a t. T plus delta t represent, so right now GT is like the area between this range and under the curve, blah 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 here. Also remember, above the x-axis is positive, under the x-axis is negative, and always from left to right. From left to right is like positive, negative. From right to left is negative, positive. Okay, anyway, so if right now it's t, delta t plus delta t, if delta t is like right now, we assume it's right now come from positive side. So t plus delta t is like here, t plus delta t, right? And what will happen if delta t approach to 0? Let's see. Close to. If delta t approach to 0, it means the distance between these two lines are getting closer, 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 closer. Closer, 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 closer. Therefore, the result. Okay, guys, wait. I will I will first explain the thing here. Okay, right now it's t and t plus delta t. And the distance between these two vertical lines is delta t, right? Okay, the thing is, if we make the whole thing getting closer and closer, so for example, currently it's like that. Okay, it's a curve anyway. So it is delta t. It is ft. Okay. Why is ft? Because remember this curve is fx. Fx. So here is ft. There's delta t. When delta t getting smaller, the shape here will be like that. Okay, a little bit. Then getting down. Delta t. Left side is ft. And when delta t approaches to 0, it will become almost a straight line. However, it's not a straight line. It's approaching to a rectangle. And the width is delta t, which is already approached to 0. And therefore, the length is ft. So guys, so the thing above actually represents the thing like that. The width is delta t, which already approached to 0, and the length of the thing is ft, and right now it's almost a rectangle. Therefore, if this part here represents a rectangle like that, and this rectangle divided by the width, which is delta t, then you get ft, right? I don't know if you guys understand this. So, after this step, we will find that g derivative t is equals to ft. Derivative of gt is equals to ft. This f is the function here, like inside of definite integrals, like that. It's really interesting. Why? Because if we know the derivative of a function and we can find the origin of the function, which is gt, because then we can find the equation about function g. By what? By indefinite integrals. Okay, let's continue. I wiped the whiteboard. Oh, good job. Good job. Okay. So if we know that g derivative t is equals to ft, therefore we can do indefinite integrals for both sides dt. Okay, and then left side obviously we should get gt, and we assume fx is one of the origin function of fx. Okay, so which means f derivative capital F derivative x is equals to small fx. Okay, so according to the rule of indefinite integrals, we know that gt should equals to fx plus c. Are we done right now? So guys, according to this, then we can get a definite integral with a t according to the definition, that's what I said, fx dx is equals to ft plus c. Okay, it's not done yet. Why? It's because we still don't know how much is c, and for here, we know it should be capital F, the thing on the top, minus the capital F of the thing at the bottom. Therefore, we have to use the thing. So you guys might remember some question. There will be derivative equation, but after you solve it, most of the time you'll get a function plus c. Therefore, they will tell you this function goes through which point. Then it will limit a set of function to specific function. For this, it's same. Why? According to the definition of definite integrals, can you guys tell me what's the area of definite integrals? AA, fx, doesn't matter which function inside, dx, okay? What's the output of it? Yes, it's 0. Why? Because you see, look at this. If you're getting closer, at the end, when it becomes the same line, so basically it's just a line. The area of a line is 0. So it's good thing to limit the c. So the thing we want to do, okay, we know that definite integral at fx dx is equal to ft plus c. So let t equals to a. Then we know that this right side will be fa plus c. Right side will be 0. Why? Because when we let t equal to a, no doesn't matter what the function, it will be 0. If fa plus c equals to 0, it means c equals to negative fa. So at the end, so right now, let's let t equals to b. Then we will get Newton Leibniz formula, right? So we know that c is equal to minus capital Fa. We place thing here, and we let t equals to b. Then we will get the formula here. That's why definite integral is related to indefinite integral. So yeah, that's it. It's all the thing I want to introduce. So it's a really interesting way to think about definite integral and understand the why when we calculate definite integral we have to do like indefinite integral, because it seems it's not related to each other. Because definite integral is something about the area. However, the indefinite integral is like an operation, reverse derivative, like that. Okay, the video is not ending yet. It's because I have to explain a little bit about the letter I use, x and t. So why is still x? It's because it describes a situation, as I said, for this function as small fx, then t, this variable, only change the upper range that we want to calculate the integrals. So when t change, the thing changes something here. It's not related to the function itself, function fx. So yeah. So t is just a random variable. It's independent with x and y. And t is just used to describe the movement. So yeah, just like that. So thank you very much for this question. And this video is for DB2 students who were interested in math. So yeah, thank you very much.